Hello everybody. In this video I'll talk about additional relational algebra operations. Relational algebra is a query language. It is a procedure query language in which users have to specify sequence of actions to extract required data. There are 6 fundamental operations within the relational algebra. First one is select, project, Cartesian product, set union, set difference, and rename. So using these fundamental operations, we can generate other operations. Now let's start talk about this additional operation. The first one is set intersection. Set intersection allows to find records which are common in two relations. Set intersection operations can be written using two set difference operations. If we are given two different sets and if we do set intersection of those two sets, we will get the common elements from the both sets. So in here I have created two tables, customers and depositors. Now we wanted to know who are the customer who have account in bank also, that means who are depositors also. So we need the name of those customers which appear in customer relation and also in the depositor relations. So what we have to do is we have to take Cartesian set intersection between customers and depositors. Okay, that set intersection can be performed using two set difference operations. Now let's see here. Now first let's retrieve the name of customers and assign the name of customers to R1. Here we can see the name of customers are Sabrina, Hari, Kiran, and that relation is R1. Similarly, the name of depositors are Sabrina, Sital, Niharika, and the relation is stored in R2. Here I have used the project operation to extract the name from this customer and depositor. Then R1 minus R2 is performed. That set difference will extract the record that exists in the first relation but not in the second relation. So Hari and Kiran are two records in R1 that exist in R1 but do not exist in R2. So the result of R1 minus R2 is Hari and Kiran. After that we will be doing subtraction or set difference between R1 and R1 minus R2. So when we perform R1 minus R2, we will get the name of Sabrina because R1 has Sabrina, Hari, Kiran, and R1 minus R2 has Hari and Kiran. The only record which appears in R1 but not in R1 minus R2 is Sabrina. So the result of R1 minus R2 is Sabrina. So in this way we can perform this set intersection between two relations, and in order to perform set intersection, union compatibility rule must be satisfied, which states the number of attributes in both relations must be same and the domain or data type of ith attribute of first relation must be same as the domain or data type of the ith attribute the second relationship for all i's. So if union compatibility is not satisfied, then we cannot perform set intersection between the relationships. Another operation is natural join. Natural join is a binary operation that allows to combine selection operation and Cartesian product into one operation. Join is denoted by symbol like this. Okay, this is the symbol for join. Natural join operation first performs Cartesian product of two relations and performs selection based on the equality of those attributes that appear in both relation schema. So what we have to understand before performing natural join is two relations must have common attribute and domain of both attribute must be same. So in here I have created two tables, members and books issued. In member there is MID, in books issued there is also MID. The domain of both attributes MID in member and MID and books issued are same. So we can perform the natural join between member and books issued on the basis of common attribute MID, and we will be checking equality between the values of members member ID and books issued member ID. Okay, now let's see how this natural join is performed using Cartesian product and selection operation. Okay, now let's suppose we want to retrieve name of those customers who have borrowed the book OS. Okay, so in order to get the name of those borrowers who have taken the book operating system or OS, first we will perform the Cartesian product between member and books issued. So initially members has 3 record, books issued has also 3 record. So the resulting table of Cartesian product between member and books will have 9 records, 3 into 3, and the number of attributes in the resulting table will be 3 plus 3, that is 6. Member has 3 attributes, books has 3 attributes. So the number of attributes will be added, number of records will be multiplied when we perform the Cartesian product between the relationships. Okay, so this is the table which is produced after taking Cartesian product between member and books issue, where we can see Sudeep is related with 3 records of the books issued, Indra is related with 3 records of the book issue, and similarly Sital is also related with the 3 records of books issue. Now we will perform equality between the common attribute of this Cartesian product table. Okay, so here MID from the member appears here and MID from books issue appear here, and we will check where the value of member IDs are equal. In the first record MID 101, here also MID 101. Okay, that is common one. Similarly here is M underscore 102, here also M 102, second record we have found matching. Similarly M 104 here and M 104 here, another also record matched. So this is the resulting table which we got after performing selection on the basis of common attributes equality on the Cartesian product table. Okay, these are the 3 records for which member IDs are equal. Member ID in the member table, member ID in the books issue, they are same. Now on this table R1, okay, this is denoted by R1, we perform selection operation. We have to retrieve the record of those records in which book name is operating system. So from R1 we will be getting 2 records, M101, M104, Sudeep and Sital. These are the 2 persons who have taken the book operating system. Now on the R2 relation, that this relation which we generated after performing selection on the R1, we will do the projection of the name from R2. So Sudeep and the Sital are the 2 people who have taken operating system book. So in this way, using the Cartesian product and selection on the basis of common attributes equal value, we can perform the natural join. Remember that Cartesian product is the one of the most expensive operation in the database, because if there are lots of tables within lots of records within 2 tables, then the Cartesian product will generate huge table. So now we will talk about division operator. Division operator is denoted by divide sign. We can see the divide sign here, and suitable for queries that include the phrase for all. Division is the most complicated operation in relational algebra, and when we have to write the SQL statement, it is very difficult. It is a tough one. We have to think a lot while dividing one relation by another relation. Here capital R and capital S represent the attribute list of relation R and relation S respectively. Relations R and S represented by small letters. Capital R and capital S means attribute list. Here R minus S indicates we have to take a difference between attributes of relation R with attributes of relation S. This means this is the difference between the attributes of one relation with the another relation. Okay, so now to elaborate this or understand this, let's consider a simple example. Here we are considering 2 tables: customer branch containing customer name and branch name, and bank containing bank name and branch name. Customer branch shows who has account in which branch. That first relation, customer branch, will let us know which customer has branch in which account. Similarly, this bank account will let us know what are the branch name of the bank. So now let's suppose we are having the query like this: retrieve name of customers who have account in all branches of NRB. Or what we can say is, retrieve the name of customers for whom there is account in all the branches of NRB. We can use this for all here. Now let's see an example here. Let's see the database tables and records. Here customer branch represent that the R relation, bank represent yes relation. Okay, now we have to calculate this small components here. Okay, I have done all these things step by step. Initially we will be retrieving the branch name of NRB bank. So this is the first expression. This is the name of the branches, and we have given this relation's name as T. This is the name of branches of NRB, and this relation is represented by T. Now we have to do this component, this one. Okay, this one. So this is done here in step 2. We are retrieving the records from customer branch. Here we are doing CNAME BNAME minus BNAME, R minus yes, then comma BNAME. Okay, here yes, in this case our yes is T, so we are having BNAME in T. So we'll extract customer name and branch name, because this branch name will cancel out. It will remain with CNAME and BNAME. So we will be retrieving CNAME and BNAME customer branch. So this is the result, and we are giving the name R1 for this table. Now we have to perform this one, R minus yes. We are projecting from R. Okay, then we will multiply that by yes. Here initially we will do this. R is CNAME comma BNAME, small capital yes is BNAME only. So this will from customer branch we will be getting only CNAME here. Okay, Sabrina and Hari, and T is our name of the branches. So we will do Cartesian product of these two tables. CNAME, this is the part 1, this is the second part. So this is the table we will get after doing Cartesian product between this table and this table. So this table we are giving the name as R2. Okay, R2. Now in the fourth step we are doing the set difference between R1 and R2. R2 and R1. R2 contains of 4 records, R1 contains of 3 records. In R1, Hari Baneshwar is the only record that does not appear in R1. Hari Baneshwar in R2, this is only the record appearing in R1 or R2 but not in R1. So our R3 will be Hari Baneshwar. Okay, this is with this result we got after performing set difference between R2 and R1. Now from R3 we will be projecting CNAME. So it is Hari only. Okay, that relation is named as A here. Okay, and the sixth step, in the fifth step we are projecting CNAME from R3. Here BNAME will cancel out and we will remain with only CNAME. In the sixth step we are generating CNAME from customer branch. Here BNAME will cancel out. So Sabrina and Hari are the two names from customer branch. After projecting this we will get Sabrina and Hari. Then in the seventh stage what we do is we will take the difference between B and A. We will subtract A from B. In case of B we are having Sabrina and Hari, and in case of A we are having only Hari. So Sabrina is the name that is appearing in B but not in A. So the name remained here is Sabrina. So what we can say here, after performing the last statement of this whole operation, Sabrina is the only customer who has account in all the branch of NRB bank. Okay, so this is a bit complicated. If you go through all these steps properly, you will understand. Okay, thank you very much for